Okay, so a couple things. I think we've covered everything on the last exam. Daniel had a couple questions. I think I covered yours. Tyler, do you have another one at all?
No, I do. We can go over it later.
Okay, we'll go over it on Thursday, and I will check back on problem set 4 for you too, Mariah.
Okay.
Yeah. All right. So the rest of this chapter on waves, we're just sort of looking at a variety of different technology and sort of where they might be. You know, good news is you could have one sitting out here floating. You could have this one near the shore, and then another one that's more shore-based. So plenty of opportunities to harvest energy. The other thing I think we might start to see when we get towards our integration chapter is we might actually see these technologies coming online as solutions for shoreline loss. You know, it's like, hey, let's build something that keeps the land as land, but also harvests energy. So another kind of a good thought for integration. Okay. Other couple different ways to think about this. So as the wave comes in, we show that any sort of point tends to attract energy. So there's a point absorber. If it's more of an elongated system, we can think of this as an attenuator. And just as the case of wind, all of these devices do, of course, slow down the wave. They have to take the energy out. So you can think of attenuation in the same way that you would in a radio frequency sense. And then terminator, think of this more like a wing, and that Bernoulli's equation where the pressure goes up and is pushing it. And it almost looks a little bit like the stuff we were doing with the wind, with a little bit of a drag to it. So it's like one little vein in a turbine, if you will. It's kind of a cool indoor testing facility. So if you've got your gadget ready to go, you can plop it in here and see how much juice it'll make. Again, a lot of concepts drawing from the horizontal and vertical wind axes. So in this case, we have an airfoil. Think of your biplane. It's symmetric, same top and bottom. And believe it or not, the thing spins regardless of direction. Might not be as efficient as possible in terms of aerodynamic sense, but it's more efficient in terms of a coefficient of performance because you're getting energy in both directions. Kind of counterintuitive, but there it is. Same principles apply. So we're just basically sticking a wind turbine in an airflow inside a wave device. Here's what it might look like. And again, think of this as, hey, here comes the tides, here come the oceans. Let's build these devices and capture some energy, and it can be a win-win. There's the turbine spinning away up top as this, blows back and forth. Here's just another example. So as this guy flaps back and forth, energy is harvested. Here it is full scale. Fun. And I don't know, you look at that, you're like, gosh, that might be a $500,000 piece of equipment, and how long is it? Well, it might be, what do you call that, 10 meters long. So if you're looking at something that's, gosh, I don't know, 4 or 5 kilowatts per meter, you might be a 150 kilowatt device. And what do I say? Maybe it's $500,000. You're looking at something that's $3 to $4 a watt, which is about what solar is. So, it's kind of expensive, but you're looking at a sort of a dollars per watt basis, and this stuff's starting to get real in a hurry. And if you are diving into the carbon market, and there's someone, or the renewable energy credit market, someone would say, hey, I will pay you to build that renewable energy device. I get your carbon credits, I get your renewable energy credits, and away we go with the new economy. So and we're starting to see that right now. In fact, this company that I recently founded, we've got some hedge fund carbon traders interested in saying, you build that and we'll do our, do what we do. The challenge for us, and what I actually just drew up this morning in my notebook. I just want to end on this little note. So I want to throw it out there, because what I would love to see happen, and this could be wind turbine, wave turbine, what have you, any renewable energy device. So here we go. We know that and I mention this frequently, up at Judith Gap, sometimes there's just more wind capacity than there is demand. So here's and you can think of this as either wind or wave, but the wind's coming in at some velocity. And again, demand is low, so basically mass obviously is flowing. You got your generator down here. Out comes the electron. The electron then spins the compressor. And so what I can see doing is in comes gaseous nitrogen, gaseous oxygen, and gaseous CO2. Once you run compressor, and again, this is allowing the wind turbine the electricity to go somewhere. And you wrote about this too, I think, in your article, saying that there's just so much dang wind capacity in Montana, we don't know what to do with it until the big transmission lines come, finally get here. Well, with the compressor, you're also storing energy. If you compress it enough, though, now you've got liquid nitrogen, which can become a commodity, so liquid N2, liquid O2, and then the next step, and this is where we'd really like to take it, is to liquid CO2, and then if this guy goes to a catalyst, and again, more on that later, then you can just let the gaseous O2 off and your solid carbon come back down. So one thing we're looking at is, too much capacity, we'll just start compressing air. And because air at 400 ppms, there's some carbon in it, and so you just sequestered carbon, and by the time you get to this final little stage, you can get to your solid carbon, and then just release that gaseous off. So
with the other, like with the liquid nitrogen, you're not you're using it as liquid nitrogen, you're not returning it to use as power. It's producing other products.
Yeah, it depends. There's obviously university buys liquid nitrogen all the time, and you could, though, you really could imagine, though, if you had that nice cold, let it do the phase change, it's nice and cold, you could imagine getting it cold enough to do some work with it.
Yeah.
Or space cooling, or yeah, right. Okay, well, we'll finish off this chapter next week. There's lots of other kind of cool gadgets out there to be had. Not a whole lot of extra stuff to cover, but we'll do that, and I'll look at that problem 4 for you as well. And yeah, what's chapter 9? Is it geothermal?
No. Yes.
Yes, it is.
Yes.
Chapter 9 is geothermal, and then 10 is integration.
Yeah.
Okay,
That's right.
that'll be good.